Welcome back, Math 2. Today we're on our 313 notes. We're going to be looking at another method to solve quadratic equations for x, and that is called factoring. Okay, so again, this is to solve those quadratic equations. Okay, so I'm going to call this factor trinomials where a equals 1 because in a typical standard form, like a normal form of a quadratic equation, it would look like this. ax squared plus bx plus c, where a, b, and c all represent numbers. Okay. So we always refer to a as the coefficient in front of our x squared term, or whatever variable it is, but our squared variable term. Okay, so we're going to work primarily today with trinomials whose leading coefficient, their very first coefficient, is 1. So if you notice in all of my examples here, it's just a plain x squared. There's no 2x squared or 7x squared. We'll deal with that in a little bit, but today we're going to get our basics down. Okay, so today this number is equal to 1. Remember, there's always like an invisible 1 we just don't bother to write. Okay. Another thing we're going to be using today is something called the zero product property. Okay. And what this means, remember, product means multiplying. I shouldn't use an X. Product means that we're multiplying. Okay, so the idea is if I multiply two things, like let's say I'm going to take T times L, some random letters, and I know that that equals 0, then that means either T or L must be 0. There's no other way to multiply and get 0 unless one or both of the letters are 0. Okay, so it means that T or L or both must be 0. Okay. Now, if that confused you for a second, hang on to it. We're going to come back to it. That's going to come in handy down here. Okay? Let's get into what factoring actually is. Okay? So what we're going to do, we're going to take these trinomials, which on their own are pretty hard to solve, just like this. I can't really set it equal to something and then start moving numbers over away from x because I have two different things that have x's on them. And they're not even x's that I can combine because one has an exponent of 2 and one has an exponent of 1. So I'm a little stuck here. Okay, so what I'm going to do instead is I'm going to factor it. And what that really means is I'm going to kind of spread it out or break it out or break it apart. Okay, my answers for these should look more deconstructed, I guess is the best way to put it. So I'm going to start with a trinomial. I should end with two binomials multiplied together. Okay. So we've done our practice where we multiply two binomials together, like maybe with our box method, and we do typically end up with a trinomial. So now we're doing that backwards. Okay, but I didn't want to call it dividing because dividing polynomials is different than factoring them. You will learn about dividing next year in Math 3. So today we're factoring, so it's kind of multiplying in reverse, but it's not dividing. Let me show you what I mean. Okay, so I have here x squared plus 5x plus 6, and I'm basically trying to figure out what had to multiply together to create this trinomial. The nice thing about having these trinomials where your first coefficient in front of x squared is 1 is that the first thing I should always have in here is x in both parentheses. Because let's think about it. If you had your box method or if you were going to just distribute this, the first thing you would have is x times x, which creates that x squared term. Okay? To get the rest of it, like what numbers have to go in here, I'm going to look at my number 6. I'm going to rewrite it over here. Because if we think about it, so our first step when we FOIL or distribute is to multiply x times x. The last thing we do is multiply this term times this term. Okay? So that means whatever numbers are here need to multiply to make 6. So I'm going to just make a quick list of all the numbers that multiply to make 6. So that's 3 and 2. 3 times 2 makes 6. Or 1 and 6. That's always an option. Okay. And you're like, okay, that's great, but how do I know which one to pick? Because there's 2 options, and they're not both right. Okay. I want to pick the option where the 2 numbers will add up to my middle number. Okay, so they should multiply to make my last term, but add to make my middle term. Okay, because I have to get a 5 somehow, and I have to get that in there somewhere. If I combine 1 and 6, that equals 7. Well, that's no good for me. So I'm going to draw a line here. But if I add 3 and 2, I get 5. So I'm going to put in here, these are both a positive 3 and a positive 2. I'm going to have plus 3 and plus 2. If you want to check your answer, you're not sure, go ahead and multiply these back together. You get x times x gives me x squared. X times 2 is 2x, which you're like, well, that's not 5. But then if I take 3 times x, I get 3x. So 3 more x's, which gives me 5x. And then 3 times 2 would give me that 6. And this is actually my final answer. This is a factored trinomial. Let's keep trying a couple more. Okay. I'm going to set up my parentheses right away. I know I have to have x times x in each one to give me that x squared. And off to the side, I'm going to draw some boxes in here. Off to the side, I'm going to say, okay, I know it needs to multiply to make this 3 on the end. So I'm going to make a list of the things that multiply to make 3. There's actually only one set of numbers. It's just 1 and 3. So we better hope that 1 and 3 add to give me my middle term 4. And luckily they do. Cha-ching. Okay. So that means my 2 parentheses, since everything is positive here, is going to be x plus 1 and x plus 3. I'm taking these numbers and putting them in here. And that's my answer. Okay. Let's try another one. It's getting a little bit more complicated now. So this one, we're still going to be doing the same first step. I'm going to put an x in each parenthesis, and I'm going to make a list of negative 28's factors. Okay, because look at these. Everything up until this point has been plus, 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 and now we have 2 negative numbers. Okay, so this is going to be a little different. For negative 28, to get a negative number, I have to take one positive number times one negative number. So I may have to try out different combinations like, oh, maybe I'll make this number negative this time in order to get my negative 3 in here as well. Okay. So, for example, I'm going to list, I know that 2 times 14 is makes 28, and I'm going to start off making the 2 negative, and then maybe the next time I'll make the 14 negative. So I might list it twice. 3 doesn't go into, 4 times 7. And then I'm also going to list 7 times 4 so I can test out all my negatives. Okay. So I'm going to add these together, and of course 1 and 28. But just using some common sense, I don't think there's any combination of the numbers 1 and 28 that could give me a 3 when we add them. So sometimes you can just boil this down to common sense. So I'm going to add all of these together and see which one gives me an answer of negative 3, and that will be the combination I put in here. So negative 2 plus 14 is 12, so that's not it. Negative 14 plus 2 is negative 12, so that's not it. Negative 4 plus 7 is a positive 3, so that's pretty close, but not quite. But negative 7 plus 4, that gives me my negative 3. Okay. So when I put these in here, I just want to make sure that there is a minus sign in front of my 7. So maybe minus 7 and plus 4. Okay. A lot of people ask, does it matter which order they go in? It does not matter on this one, whether you put the minus 7 over here and the plus 4 over here, that doesn't matter. Okay? You know what, let's skip this example real quick, and we'll move on to this one. So I have x squared plus 16x plus 64, so all nice positive stuff here. Put my x in each one, and then I'm going to list my factors of 64 that I think will create 16. So first off, 64 has obviously 1 and 64. There's 2 and 32. Does 3 go into it? No, 3 does not go into it. There's 4 and 16. And then there's 8 times 8. There's probably more, but I'll stop there for a second. So if 1 and 64 gives me 65, that's not it. This would be 34, that's not it. This would be 20, nope. 8 and 8, that gives me 16. Okay. So I'm gonna have x plus 8, x plus 8. Okay. Now here's the thing, if you notice, this is the exact same thing in both parentheses. So if you have a situation like this where it's the same thing, we're going to take it one step further and write it like this. X plus 8, all in parentheses, squared. And this is because I'm taking the same thing times itself. So we are going to use an exponent of 2 to represent that. So this is why in the past, when you're like, can I distribute the exponent of 2? No, you cannot, because this actually means this. I'm taking x plus 8 times another x plus 8. Okay. So how does this all help us? Okay. I'm going to go back up to that zero product property real quick. Remind you that when we multiply two things, if they equal 0, one of those two things must equal 0. Okay. So let's bring that down here. So to solve a trinomial after factoring, you notice all these problems are set equal to 0, and previously they were not. So I'm going to start with factoring, and then I'm going to show you how you can actually solve. Okay. So here's our example. It's the one I crossed out earlier. That's why I didn't bother doing it. Okay. So I'm going to start. I'm going to leave it set equal to 0 so I don't forget about that, but I'm going to start with factoring. I have a positive 12, but a negative 7. So I need to multiply to make positive 12, but I need to add to make negative 7. When this happens, all of my factors must both be negative, because to multiply to make a positive number but add to make a negative number, we must have both numbers being negative. So I mean negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. Because if I multiply those, I get positive 12, but if I add them, then I will get a negative number. Well, 1 and 12, that won't work. 2 and 6 makes 8, not quite, but it's going to be negative 3 and negative 4. So I'm going to put minus 3, minus 4. Okay, so far this is what we were doing up here. Here's where it gets different. Okay, because I'm set equal to 0, and I know this zero product property, if I multiply two things and it equals 0, one of them must be 0. What I'm going to do is I'm going to separate them and find out, okay, when does each one of these equal 0? And those are going to be my two different solutions. You know how with the square roots we ended up with two solutions? So I'm going to have x minus 3 equals 0 separately from x minus 4 equals 0. If I solve each one by adding 3 to the other side over here and adding 4 to the other side over here, I end up with x equals 3 and x equals 4. So then these are my two solutions. These are the two spots where my graph is crossing the x-axis. Let's try another one. Sometimes it's not always 2, remember? So we already factored this one up here, so let's just copy that down. If I have x plus 8 all squared equals 0, remember what cancels out a square? A square root. So I'm going to take the square root of both sides, and I'll have x plus 8 all by itself, still equal to 0 because the square root of 0 is 0. And now I can solve this, and I get minus 8, and I get that x equals -8, one solution. Okay, remember that happens when the graph is just touching right there at -8. Okay. All right, let's try one more. I know this is kind of a long video, but this is really important we understand this now. Okay. I have x squared plus 4x minus 45 equals 0. So I'm going to use this space over here. -45 is what I need to find factors of. X and x equal to 0. Now because this is negative, I need one positive number, one negative number. So let's see, there's 1 and 45. I don't think that's going to give me a 4 anyway. 3 and 15. I'll try those. And then let's see, 9 and 5. Okay. So let's see what we get. -3 and 15 would be 12. I have -12 here, so it's not those. -9 and +5 makes a -4. So we're really close, so it must be -5 and +9. Okay. So again, it doesn't matter which one goes where as long as the negative is in front of the 5. Okay. All right. And then to finish solving these, I'm going to separate them and solve x minus 5 equals 0 separately from x plus 9 equals 0. And the nice thing about this is it always ends up being a simple one-step problem. This side I have to add 5. This side I subtract 9. So I'm going to get x equals 5 here, and x equals -9 here.